Let's take our discussion of relations one step further and start talking about what a function is. So, we're still modeling relationships between different things, between different quantities, but today we're going to determine what relations are something even more specific called a function. And we're going to look at mapping diagrams, we're going to look at sets, we're going to look at tables, and we're going to look at graphs. So, what I'd like you to do is to start with your book open to page 285. And the very first inquiry question we see is, how can I determine if a relation is a function? Now, remember that a relation is something that connects two things. That was our last discussion, and you can see that X matched with a Y in a point. You can see that X matched with a Y on a graph. And here we're going to just take that idea and talk about some people, let's say, in math class. So Mrs. Hanel asked three members of her class their favorite color. The mapping diagrams below are going to show some results. So in her first class, she asked Amber, Tim, and Kayla, and Amber's favorite color was blue, Tim's was red, and Kayla's was green. This relates a student to a color. That's the relationship. That's the relation. And this is a function, our new word. This is a function. Okay, well, let's look at another example. So in another class, she asks Alonzo, Melina, and Chen. Alonzo says his favorite color is blue. Melina says her favorite color is blue. And Chen says that his is green. This is also a function. This relation of this class students to colors is not only a relation, it's a function. Okay, still not sure what this function thing is, but let's look at the next class. So she asks Elena, Haley, and Tony. Tony says green and Haley says red, but Elena says blue and red. This is not a function. Okay, Elena, you need to make up your mind, girl, because she didn't really do what she was asked. She named two colors. She didn't give a favorite. She named two. So these are called mapping diagrams. They're another way to show relations. But in this case, if you notice, Elena kind of messed this up. This one is not a function. Yes, yes, no. So if we take a look at those, and let's talk about what a function is more with our math terms. It's a special relation in which each member of the domain, your inputs, right, is paired with exactly one member in the range. So each person can only have one color. So in the mapping above, this relation 3 is not a function because this member of the domain, Elena, is connected to two members of the range. So this input has two outputs. So this is not a function. So let's take a look at a more mathematical one. So we're going to make a table of this set of points. Your book likes to make their tables go horizontally, left to right. You see, when I make tables, I like to make them go up and down because then the X's are on the left and the Y's are on the right. It just makes it easier. But we just have to realize that the book does show them this way, and it's fine. We can show and represent these in different ways. So our domain, going back to our last video, that would be the set of X's. So there's a 0, a 1, a 1, a 1. So the members of the domain are going to be 0 and 1, and I'm going to put these points here. So there's the 0, the 1, the 1, and the 1, and then it was 0, -2, and 1, -2, and 1, 3, and 1, 8. And then if we look at our range, it would be -2 and 3 and 8. And remember, we don't repeat members in the domain and range. Let me just squish that down a little so you can see the negative. We don't repeat members in the domain and range. So the domain would be 0 and 1 for this particular set of points, and the range would be -2, 3, and 8. And I'm going to make a mapping diagram. So I'm going to connect the 0 to the -2, the the 1 to the -2, the 1 to the 3, and the 1 to the 8 with arrows. And can you see this mapping diagram? And a mapping diagram really can show you that this 1 is coming out with 3 different answers. So, is this relation a function? And because we have a member of the domain that's connecting to 3 members of the range, that's a big and that would be a no, because that number 1 has 3 different outputs. So it's really easy to see on a mapping diagram. So if we go back to the table, if you look at the table, how can you tell if something is a function? Well, if you look at your x values, if there's a repeat on your x, meaning that an x gets repeated and sent to different y's, that tells you it's not a function. So if I just look down the list of the x's, the 0, the 1, the 1, the 1, because this 1 repeats in the x's, not the y's, in the x's, this is not a function. So here is kind of that page. In case you need to pause the video for a second, please do that if you need to have this page perfect in your notebook, okay? Okay, so now we're going to kind of go off the book for a second to just do some examples. So we're going to start with a word that's missing up here. Any set of ordered pairs, an input, comma, and output. So it can be shown in a table. It can be shown in set notation of a set of points. It can now be shown in a mapping diagram. What are all of these called? Relating that x to the y, that input to an output, is called a relation. Now we're going to kick it up a notch this time, and we're going to say that there's a relation that assigns exactly one output for each input. What is that called? And that's our new word, which is a function. So if x is the input and y is the output, there can only be one value of y for each x. And if we look up here, if we just look at this mapping diagram, you can see that this 0 is an input. It goes in and comes out as a 0, but then it goes in and it comes out as a 4. Because there are 2 y's for this x, this is not a function. Okay, so that's kind of what we're talking about today. So what we're going to do right now is just walk through some examples. It's pretty easy to see on a mapping diagram. Now let's talk about how do we know if something is a function if we are looking at a table or a set of points. And oh, by the way, these are basically the same things. This is just showing the points going down, which would be vertically, and this is just showing the points going left to right, which would be horizontally. It's the same idea, just 2 different ways. So what I want you to do right now is look at number 1 and just see if you can decide, do you think this is a function or not? So it's a yes or no on this. Okay, so did you say that it is not a function? And the reason it's not a function is because we have this member of the domain that is going in and coming out as a 3, and then it's going in a second time but coming out as something different. So the input of 2 has 2 different outputs. That's not a function. Well, if you didn't understand it on that one, how about trying number 2 right now? Is number 2 a function? This time, if you look down the x's, every x is unique. Yes, 12 and -12 are different numbers, okay? So the 12, the -12, the 3, the 0. Notice there's no repeat on your inputs, on your x's, so this would be a function. Notice I didn't even look at the y's. 12 going in and coming out as 10, and -12 going in and coming out as 10 is okay. That's kind of like Susan picking blue and Ted picking blue. That's okay. But we don't want the same input to have 2 outputs. So this would be a function. Okay, try number 3. So 1 is different from -3, is different from 2, and then that 1 and that 1, because there are 2 repeats on our inputs with different outputs, that would be a big no. Last one to try for tables. And this one, did you say yes? You basically just look down your inputs, your x values, and if they are all different, it's a function. Now you got to be careful here. Same idea, but look at it horizontally. Did you say yes? So we have an x of 5, we have an x of -5, we have an x of 1, This is good. Last one, number 6. Right? What was the problem? See the 0x here and the 0x there? So 0 goes in and comes out as 0, and 0 goes in and comes out as 3. That's not a function. So that's how we can look at a relation on a mapping diagram, on a table, and on a set of points and determine if it's even more special than a relation, is it a function? So now let's talk about the graphs. So remember that we can graph a set of points. Now I want you to bring in our science words here, but remember that your x is your independent variable. We're going to start using that term from science. It's the one that you get to pick. You are independently picking the values. We'll talk more about that in future videos. And your y on the y-axis is called the dependent variable. I just want to get those terms out there because we'll be using those more and more as we go forward. Remember that a set of ordered pairs is always alphabetical. It's always x before y. It's always your independent variable in front of your dependent variable. Okay, here's a set of points. Now you already can look at this and know whether this set, whether this relation is a function. So take a look at it and see what you think. Well, -2 for this x, 0 for this x, and 2 for that x, all the x's are different, so this is a function. And we can graph the function. So -2 and then up 2. Remember, your x is always your first, so the second one, 0, means don't go left or right, and that 2 means to go up 2. And then finally, 2 means to go to the right 2, and that -2 is to go down 2, and there are my 3 points. So you can show a set of a relation or a set of points. You can show it on a table. You can show it in a set of points. You can show it in a mapping diagram. You can show it on a graph. Now, how do we know if this is a function if we're just looking at the graph? Well, let's take a look. Let's look at a table first. So let's say this was our graph, and we're going to put the points. So I'm going to write the points over here in the table. So when I had an x of 2, notice that I had a y of 0. So 2 comma 0. When I have an x of 0, notice right here, 0, it's 2. So I'm just listing some of the points. I'm going to list all of them actually. And then I have a 2 here, and its output is a 4. And you can hear my cat crying in the background. Can you hear her? And then a 4, and then a y of 2. And then finally a 6 and a y of 4. My husband came and shut the door. Thank you, Mr. Woodruff. Anyway, so there are my points. I look at the graph and I want to know, is this a function? And so what I'm showing you this time is I'm going to make the table. So I labeled them all, the points with their x and y coordinates over here. We don't have to do that in the future, but we're just trying to figure this out. So when we look at the graph, is it a function? Well, let's look down here. Now notice, guys, look. Do you see the repeat of the 2 on the x? So when you look at this table, you know that this is not a function. So let's see where this shows up on the graph. So 2, 0, and 2, 4, you see those 2 points? And I want you to notice that they lay on the same vertical line. Okay, do you see that line I'm tracing there? When you have 2 points on the graph that lie on the same vertical line, it's not a function because that x has 2 different outputs, 2 different y's. So we don't have to go through all of this trouble of writing out the table. We can look at the graph. And this is called the vertical line test. Okay, that's what we're going to do. So if you have a graph, all you need to do is take a vertical line. And remember, a vertical line goes up and down. We're not talking horizontal or slanted. So we take a vertical line and you pass it over your graph. And if that vertical line hits more than 1 point on that red graph at any one time, then it would not be a function. So if you pass a vertical line, if the vertical line ever touches more than 1 point at a given time, it's not a function. But you notice as I pass this, I only hit 1 point on the red line at a time. This is a function. Now, wait a minute. Then what would one look like that's not? Well, here's an example. And if I take my vertical line, you can already see that right here, when I hit those 2 points, or that part of the graph, I'm hitting 2 points at the same time on a vertical line. Over here, if I move the pencil over here, I'm actually hitting 3. 1, 2, and 3. And what that is saying is whatever x value this is, it has 2 y's, and that would make it not a function. So I'm just going to go back to the first one that we did here. And if we were to take a vertical line, which I'm just going to go and grab one here. So here's a vertical line. And if I was to take that and pass it over this graph without having made the table, I'd be like, oh, that's good. Yep, that's good. And they're right there, right? See how you hit 2 points. So even if it's a set of points, you can pass a vertical line and cross and see that it is or is not a function. So this one is the big no. This one is the big yes. And this one is another big no. So now your turn. I'm going to give you 4 here that you're going to step through, and you're going to give it a yes or no. Is it a function or not? So let's start with the upper left. So did you say yes for this one? See, as we pass it across, it only hits 1 point at a time, so that's a yes. Let's go to the upper right. Let's see. 1 point, 1 point, 1 point. Not a function. How about the lower left? Do we even really need to pass this across? Look, this is an oval. It's called an ellipse in math speak. And notice it's hitting 2 points everywhere except the very tippy point on the left and the right. But the minute you hit 2, this is a no. So that would not be a function. How about the lower right? And this ray has an arrow on one end and an endpoint on the other. We never hit more than 1 point with our vertical line. So this would be a function. So we had a yes, no, no, and yes. So today you came up with a new word, and I cannot begin to tell you how important the word function is going forward in math. It is sort of the foundation under a lot of things we're going to do in algebra next year. And all the way up through harder maths like calculus, things are based on function. Normally in the back of my room, can be graphing calculators. They're the big yellow calculators that we sometimes get to use. They only graph functions. So understanding what a function is really important as we go forward in this unit. So it is time to put away our movie for today. And when I see you next, we'll do some practicing on is a relation a function. Hope you have a great day.